so fucking crazy. Excuse all the excuses and excuse you again. Maybe if you made some changes, so sick of saying refuse is what the truth is, no solution again. In a world that's ever changing, no cadence. Proof is in the pudding like improvement. Oh, just run away, run away. Oh, just run away, run away. Running from your problems, what you running from? Running from your problems, what you running from? Please stop playing this game, there's no escaping. Quit obeying. The man in the mirror is really no man at all. Gravy, details are so hazy. Ghost Patrick Swayze, stand and deliver or don't stand it all. Oh, just run away, run away. Oh, just run away, run away. Running from your problems, what you running from?
Well, welcome back to Intuos Intuos Designs. I actually own another company called Intuos Communications. Sorry about that. We got a special treat for you guys today. I know I say a lot. I got to stop doing that. So, we do have a very special thing for you today. Man, I gotta add something real quick here, Sorry about that. You guys get to see me screw around here. All good. If you don't know anything about OBS, here you go. Pretty crazy. There we go. Lock that one in place. So we actually have something very special for you today. We are going to be showing you guys how to make a printed circuit board with a fiber laser. This is actually really cool. It takes a little bit. You got to get used to things, and you got to know what you're doing. Otherwise, you'll spend a lot of money in printed circuit boards and in circuit boards themselves. You know. So what we're gonna do is that you see this double-sided copper-clad printed circuit board material. So the very first thing that we're going to do is get up and we're going to grab some paper towels. At this point, I only use a regular paper towel. I'm not really worried about any dust or anything being on the circuit board. We'll clean it up a little bit later on. So what you need to do is make sure that you have 100% or 99.9% alcohol, and you spray the circuit board and you clean it off so that you don't have any oils onto the copper. And you'll see if there's any oil on the actual copper, copper, because it shows up pretty quickly. So you flip it over and spray the other side with a generous amount of 99.9% isopropyl alcohol. And then, sorry about that, man. I cut my finger pretty badly with a pair of scissors, believe it or not. And I just got alcohol in that cut and it hurts. So once you're done cleaning up the board, you want to go ahead and put it onto your work area. And we're gonna go ahead and get some gaffing tape together. If you don't know what gaffing tape is a material tape. It holds kind of like duct tape, except for it's not made out of a plastic or a so what you want to do is grab enough gaffing tape. I use 3-inch gaffing tape for the calibration stuff. So I don't buy a ton of gaffing tape. I just bought a 3-inch, and you can get that from Amazon. So then I take the 3-inch gaffing tape and I cut it in half straight down the center. And then I lay them, just stick them to my desktop loosely. So we're going to go ahead, and it's going to get a little noisy now because we have to turn on the fiber. Laser, sorry. And then we're going to go ahead and bring up the fume extractor as well. So now we're going to open our project up in Lightburn. And, what it comes up, I've made a few different layers because this is a 2-layer board. It's front and back. So this particular board, I found it online. It is not my design. I did have to rework it because the design was not totally proper. So I had to run it back through KiCad. If nobody knows what KiCad is, it's a electric circuit design program. It's open source. It's free. It also helps you create printed circuit boards and engineering in electronics. So this is the front side. There's actually a couple of layers that I have active right now, and that is the actual front of the circuit board, and then the edge cut around the outside. So what I'm going to do is I'm going to go ahead and turn off the actual circuit board itself and just leave the outside cut edges. And I'm going to go ahead and frame it right now so that I could see where on the laser that this is actually going to be. So I'm going to move everything. And the very first thing you want to do is make sure that your laser is actually focused. Okay. I made a mistake a lot with not focusing the laser. And then all of a sudden, there's a lot of problems. So what we need to do, I'm actually not putting this near the edges of the board because I'm going to use the remnants of after I cut out. I can actually get 4 of these circuit boards out of this particular piece of copper cladded PCB. So I'm going to move it in because I'm going to make a template. You'll see why in a minute. So I'm going to line this thing up, and then I'm going to take my gaffing tape and I am going to actually cut my gaffing tape into 2 separate pieces, actually multiple separate pieces, and you'll see why in a minute as well. And then I'm going to go ahead and tape down this at the top, and making sure that the edge is really adhered to without the side being down. But you want to make sure that you have a really good seal, because you don't want your printed circuit board to move, because you won't be able to complete everything if you don't. So we're going to cut another piece of gaffing tape, and we're going to go ahead on the outside edge here, and we're going to go ahead and nail that side down too. It's pretty strong tape. Okay, so on grab another small piece of gaffing tape, and then what we'll do with that is we'll put it on the side over here to keep it square. And held down pretty well. So what we're going to end up doing is we're going to go ahead and show you right here everything that I did. I put gaffing tape up at the top right here, and I put a gaffing tape here, and I put gaffing tape here to hold it square. Now, after we're done lasing this side of the circuit board, we have to actually use this as a template to place the printed circuit board back in there, oriented so that it can actually do the other side, and that all the pins and the holes are going to line up. So we have everything square and ready to go now, making sure that everything actually grab my trusty dusty little pair of tweezers here and just make sure that I've really got that on that edge really done well, really tacked down and holding well. All right. So you can see the area that we're going to actually laze, and we are going to turn back on the so we're going to go ahead and turn back on the front side layer for the printed circuit board. Now, the settings that I'm using here, I'll go ahead and open that up real quick. The settings that I'm using here are 1000 speed, so it's 1000 millimeters per second, using 100% of the laser power, using a frequency of 40, a Q pulse width of 200, and we're gonna use 0.05 in the line. Distance between each line is 0.05, and then we are going to scan. The laser is going to scan at an angle of 45. It's going to be 4 passes that way, and each time it's going to increment by 90 degrees. So each pass it's going to rotate 90 degrees. So we're not hitting the printed circuit board at the same pass. It's not going to start in the same place. And the reason why we want to do that is because even though that you're using a laser, and the laser is very quick and it doesn't hold a lot of heat to the board itself, because it dissipates very quickly, okay? But lasing such a large area, everything that's in black that you see and red. Everything in black will be lazed, and the red is actually a line, and that will cut the actual board out of the entire piece that we have sitting there. Another thing that we have is we have a cleaning pass. So after the 4 passes happen, where it's actually, totally etched out the board, it's going to take 2 passes and clean up. That's at 1,500 millimeters a second. The maximum power we're going to use is 20%. And we are going to use a frequency of 100, a Q pulse width of 200, and we're going to use the same line distance of 050. Then we're going to start at an angle of 135, and there's 2 passes, and we're going to also increment the angle every pass, auto rotating by 90 degrees. And then after that's done, it's going to cut the board out, but we'll show you that. It's going to use 100% of its power. It's using a line speed of 100 millimeters per second. Yeah, a lot slower. A frequency of 40, Q pulse width of 200, and it's going to take four times around to actually cut the board out. So we'll go ahead and say okay, and you can see over here that these 2 layers are turned on. And then I will switch over. I'm going to switch over to the laser cam, and that way you can see this is actually really cool. I really like this part because when you're doing a printed circuit board, it doesn't really take a lot of time. It's very high line speeds. It's a very high speed, and it goes very quickly. So it's going to take 5 to 7 minutes to actually do each side. So you're talking about 15 to 20 minutes for the whole entire process to be totally complete. So without further ado, here we go. If you guys got any questions, the chat is open. You can ask me questions about what's going on and how things are done. Anything you want to know about laser engraving, I can help you with. I am not a proprietary person. I actually help. I don't believe that, there's plenty of businesses that could do laser engraving, and the more the merrier. There's plenty of work. There is definitely plenty of work. I specialize in printed circuit boards, and I specialize in firearms. So rings, jewelry, things like that. A few people are telling me they're sending messages in chat, but I don't see anything coming up. I'm going to have to check and see what's going on there. I guess I have an issue. We'll wait until after we're done doing this and this live is over before we go mulling around trying to figure things out. You'll notice how the laser hitting the board has changed colors from the very first pass. The reason why is because underneath of the copper is a type of polymer. It kind of looks like fiberglass to a certain degree, but it's not fiberglass. You want to make sure that you have good ventilation and that you definitely have a fume extractor when you're doing this. That is some very noxious fumes that are coming off of there. Hopefully you guys are enjoying this as much as I am. I absolutely love seeing this laser work this way. Pretty soon, I think we got one more pass to go through for the actual lasing itself. So right now what's happening is when the laser's going across there, it's called ablation. Ablation is absolutely pulverizing, or what's the word I'm looking for? It just totally obliterates the material. So it turns it into vapor. You definitely don't want to put your hand under there. You end up with a nice tattoo. That wouldn't be good. A see-through tattoo at that. And there you can see the laser change into the cleaning pass, and you can see how the darkness starts to disappear behind there. So with ablation, you're going to have some carbonization, and that is cleaning the carbon off. Yeah, you definitely don't want to put your hand under there. Not at all. You will definitely be able to see through your hand afterwards. Almost finished up with the cleaning. Well, you got one more pass of cleaning to do. Again, you always want to rotate in things like this. You don't want to have too much heat on the board in one place. So letting it cool down, as it goes along, it gives it enough time. That way the board doesn't warp. There's more to this process after we're done. You have to put a solder mask on, which in the other room I've already done. I've already, put some solder mask on some of these boards. The solder mask is a liquid, kind of like an epoxy, except for it's activated by UV light and hardens when UV light hits it. So obviously, you don't want to do that outside in the daytime. All right, now comes the even better part. This is where we start cutting through the board, and it gets kind of fiery. You're going to love this. Yes, sir. It's pretty cool. You can actually see the laser beam. This particular PCB is making what's called a multi-boy. It's on GitHub. And what I've decided to do is actually make a few of these and sell them. I had to fix the design. It had some issues, so now it's all cut out and everything. So what we're going to do now is we have a little blowgun. You can't see it. I'm actually don't have a camera on me right now, but we're going to blow all the debris off. Make sure it's all cleaned up, that we don't have anything left over.
I'll watch the sunrise over downtown, turning me into a town.
So now that we have that, what we're going to do is we're going to actually stop the laser from framing everything, because it's in a position when you actually start framing, it's actually in a position to where it's ready to fire. Right now, it's not ready to fire, and it's safer to put your hands in here. So what I'm going to do now is go ahead and take the one edge off, and I'm going to lift this directly up and remove the board from underneath and put down the template again. And then I'm going to take a brush and just gently brush anything off of here that might be in the way. Now, the way that I designed this cut is that you actually take the board and you turn it directly over. Now, when the laser is actually cutting out the design, the outer edge of the board, it uses a setting called wobble. So I'm going to turn back on to the other camera so you can see what I'm about to do. Okay, so here's the printed circuit board. Here's the other side. And you'll notice that it's got a charring around the outside edges. We're going to take care of that in a second. So because of the carbonization after the cut, what we want to do is we just want to take a little bit of this is I think it's 400 grit sandpaper, and clean up the outside edge on everything so that the carbonization is removed from the actual edge of the board. And then, once that is completed, blow everything off again. And then we're going to grab another piece of paper towel. Clean up all the carbonization and any soot that is still laying on the board. Another reason why you want to sand everything on the edges is because it does leave little splinters of copper, which I'm pulling off right now. Those splinters can actually come back onto the board and cause you an issue later on. Kind of sand this up a little bit more. So we have a nice edge. You don't have to clean it too much. Just try to keep the oil off of the circuit board. Now, so the way that I actually designed this is this is the actual top of the board up here. So when I place this back in, I'm just going to flip it over on the left edge of the circuit board and place it back into the outline of where it was cut out at. So we have it, and you can see just like this. And now all I'm going to do is flip it and stick it back into the hole that was cut. Okay. So now what we're going to end up doing is back in light burn, what we're going to end up doing is we're going to go ahead and turn off the outside cut. We're going to turn off the actual front side, and then we're going to turn on the back layer for the actual cutting of copper. That's what CU means, is cutting copper. So that's the layer we have turned on now. And then we're going to go ahead and set the frame and start lasing again. You see how bright that is right now? That's because it's actually reacting to the copper. When it starts to go a little bit more yellow, the copper's gone, and it's actually just eating the board. I hope you guys are enjoying this. You can see we're almost finished with that portion of it. Now, I don't know how the next part is going to go because I haven't really tested out the next part. So hopefully it goes well. Some of the stuff that you're not seeing is that, you know, you have to put a solder mask, like I was saying earlier. You have to put a solder mask onto the board itself. And, you know, you can use all sorts of different colors, green, blue, red. They have all sorts of different colors in solder masks. It's a liquid. You have to use a silk screen to put it on, and once you actually layer it with, you know, you go ahead and coat it with the solder mask. Then you have to use a UV light to harden the solder mask. Hopefully, I let this one be on that. You know, this one didn't turn out all that great. I was in a hurry because I wanted to get this done for you guys. If you do it a little bit slower than I did and you do it properly, then it won't look as weird as mine does. You'll see in a second as soon as I replace everything with the board that's got the solder mask. And what you're going to see after I start doing this again is that I have another layer which is going to remove the solder mask from the pads. And, you know, once that's done, well, actually the very next thing is to drill the holes with the solder mask on there. The reason why you do that is because you have to use 100% of the laser's power in order to drill the holes. And you know, with the solder mask on there, it helps, you know, when you're using that much power in the laser, not to knock off the solder pads. So not exactly sure how it's going to work out, but sorry, my cat was in here. That's why you hear me grunting. I was trying to move her out because I don't want her to get anywhere near the laser. I don't need a hole through my cat. So as I was saying, you know, we do have to drill the holes through each one of these pads. And in order to do it, we have to use 100% of the laser's power concentrated into very small pinpoints. And that is a lot of power hitting the board all at one time. Excuse me 1 second, I'll be right back. Alrighty, I made it back in time. So here we go. I'm going to go ahead. We're almost done. This is only going to take a second. So I'm going to blow off all the debris here. I'm going to go ahead and stop the framing, and then I'm going to go ahead and remove the tape from the side of the board again. Lift this up, go out the board, lay it back down. Now, coming in to the frame, you're going to see the board that is already, and I'm going to go on the front side. Front side. That already has the solder mask on there, and we're going to go ahead and turn off that layer. Now there are two different types of holes in making printed circuit boards. The really tiny test holes that are places for automatic testers to actually check the printed circuit board for short circuits and stuff like that. So we'll go ahead and we're gonna the small holes will be first. We're just gonna turn on that layer, okay? And as you can see, I have 100%, and I have it set to four passes right now, and I'm gonna reduce that down to 1. And I'm going to go ahead and hit, start every single time. I want to look and make sure that those holes are being created properly. So I'm going to say okay there, and that'll help me do the bigger holes. So if you can see the screen, you see all these really small holes all over the place, little dots. So we'll go ahead and frame them out. And once we actually start the frame,